I just feel like I have a
So let's get started. And yeah, a couple of announcements. So first of all, some of you are already forming teams for the project, which is good. So let me know when it's ready. And typically what I do is just create one extra tab on the file so we can keep like the documentation of the progress and information. And also know that so I emailed you all the other day that if you have questions or problems working with our markdown file, come to office hours. I know I only have 1 hour tomorrow and then only one Monday afternoon, but any of the TAs will be able to help, so just email them directly. And so we do have homework 2, which is due on Tuesday. So hopefully everybody is making progress on that. So I just want to know about lab 1, which we started last time. Originally, I made it due on Tuesday as well. Is that doable, or you think you probably need more time to work on the markdown file, so we make it to be Thursday? I'm fine either way, so you can let me know now which one you prefer. So, Thursday? Okay. All right, so we're going to do Thursday, and I will. Okay, thank you. And okay, so we're going to do Thursday for lab 1, but homework 2 will still be on Tuesday. Okay. And all right, I think that's most of the announcements. And in case you do have questions about lab 1, next Tuesday when we come back from the weekend, maybe I can spend some time just talking about the material itself, because last time I think we mostly just got to talk about, well, how to work with the markdown file. Okay, so I'll plan on doing that. And so today we're going to start this new unit, Bayesian inference for a mean. And you will see that we're going to do very similar thing in a way that we will try to work out what is the likelihood function, what will be a proper prior distribution for a particular unknown parameter, and then work with Bayes' rule to figure out how to get the posterior. Okay, so we focus on continuous outcome for this unit. And typically, we're going to use a normal likelihood function for the unknown or for the observation. So we're going to start with an example. It's the expenditures variable in the consumer expenditure survey, and then we're going to move to talk about prior and posterior distributions. So remember, we're going to do normal for the expenditure using the normal distribution for that. Then the normal random variable has mean and standard deviation, right? So we're going to work with both of them. And then towards the end, we're going to have lab 2, not today, later, that we're going to work through different inferences questions for the unknown mean. Okay, and then we're going to recap. So for the example, the consumer expenditure surveys data, we call it CE for short. It's conducted by the US Census Bureau for the Bureau of Labor Statistics. And in particular, it contains data on expenditures, income, tax, statistics about consumer units. We call them consumer units, but you can think of them as households, okay? People living in the same, under the same roof across the country. So overall, it provides information about the purchasing habits of US consumers. So what I want to show you is if you're ever interested about the particular survey data itself, you go to their website. The consumer expenditure program, they actually release this data in 2 formats. One is tabular data, like aggregated, maybe like say for this particular period of time, for this particular age group, for this particular geographic area, they give you a count of certain type of things. So that's what we call tabular data. But they also provide something what we call micro level data. They call it pub use microdata at PUM for short. And it's actually releasing data at the individual level. In this case, it's at the CU level, meaning that you can get certain information about each CU in that particular survey data, okay? So we're gonna work with micro level data, and overall it's more interesting, especially if we think about that I want to, later on in the semester, you will see, well, if I want to run a regression analysis, you want to work with the micro level data, okay? Aggregated data or tabular data whenever it gets you there. So, so we're going to work with that. And for this unit, we're going to work with this continuous variable, TOTEXPQ. And what it means is the CU total expenditures from last quarter. Okay. So it's a continuous variable. We're going to plot it. I'm going to show you the density plot for it in a minute. And we work with a particular sample, which is from the first quarter of 2017, and we have a little bit over 6,000 observations in that. Okay, so just keep that in mind. It's at the macro level, meaning that we have information about each of the CU. All right, so to plot it, notice that from now on, I will probably start adding like data sets into Moodle for you to download. So this is the cesample1.csv. So you should download that data into the folder, and then you can load the data using the read_csv command. And I hope, since most of you have finished the introduction to the tidyverse course, you will see certain use of that starting to appear. And you can provide, so this is, this two commands actually are not from tidyverse, but this is basic R that you can return summary statistics about a particular random variable. So here we have the total expenditure last Q. That's the name of the variable, and then you know you can get the $sign through the data set sample, data set name to get access to that particular variable. So you can look at the mean, median, max, and the first quarter and the third quarter. And what you can also do is get the standard deviation. So what I want to do is just to give you a sense of what this variable is like. And you can also plot it. And here is from ggplot, and we are plotting the density function of this. So if you start working with ggplot doing other stuff, you can see that for density plot, this is the particular command that you need. Okay? So the size is about like how thick those lines are. Okay, and down here, this is changing the title of the plot, and then this is changing the font size of the legend. Okay. All right, so this is the variable that we work with, and if you remember, I was saying that we're going to assume normal distribution for a random variable, and do you think this is a good choice? Okay. Many of us know that normal density, well, it has its own mean and variance or standard deviation, but it should at least be roughly bell curve symmetric, right? So this one is a little bit off, but maybe some of you also know that whenever we try to work with continuous variable, we can take certain transformation of the variable to make it more normal. At least right now, that's thinking that way. So one thing you can do is you will see that we're going to take the log transformation. So this is the simple script that you can do. You take the log of this total expenditure last Q, and then create this, assign this to a new column of the sample, and then you can plot that. So this is much more at least symmetric and bell-shaped, right? And then the goal here now is that we're going to work with the log transformed variable for this total expenditure from last quarter. So we call this log total exp last Q. And we're going to try to learn about the mean of this variable, okay? So the goal here is that this is the data that we have. We're working with the log transformed version, and we're trying to put a normal density or normal distribution for this data itself, and then trying to learn about its mean. So keep that in mind, and we're gonna come, before we start the process, just really quick review here. Normal distribution of symmetric bell-shaped distribution. It has two parameters. We're going to work with mean, mu, and standard deviation, sigma. So you will notice that throughout, I'm using n parentheses mu and sigma, and that's talking about the mean and standard deviation. Okay. So the density, which we actually saw in the introduction when we're doing probability review, is that this is the density, the PES of a normal mu sigma. And I think, especially in homework 1, you perform the exercise of trying to derive the joint density of a sequence of observations. So this is just one. Okay, this is just for a random variable y. That's what you have. But then, if you have a sequence of them, you'll be able to take the independence condition, so you're able to write out the joint. Okay, so this is, again, example of different normal curves. And by the way, this is just from ggplot too. And on the, I think it's the, whatever I uploaded for the for this unit, I have the R script in the R markdown file. So if you want to know how to plot things like this, yeah, look, yeah, go to that file and then play with it if you want. So basically, you can see that normal, we know that it has mean and sigma. Okay, mean is where it's centered. So if you look at normal, let's see, normal -2 with mean -2. So that's this the red curve here, this one, and it's centered at -2. Okay, and the other parameter standard deviation, we know that is measuring the spread. Okay, so the larger the standard deviation, the bigger the spread you will see of the normal distribution. So if you compare this two, both are centered at 0. So it's this bluish and the other greenish curve, this two. So you can see that normal 0, 2 will have a bigger spread. Okay. Push down a little bit, but both of them are still centered. Yeah, I should say this one. Oh, sorry. This one is the, anyway, you know what I mean. So it's all the other ones here that is centered at 0 and then with different spread provided by the different values of the standard deviation. Okay. So keep this in mind. And lastly, this is what we reviewed in the probability review, but I just want to mention this again, that we're going to suppose that there's a sequence of n responses. We use capital letter to represent the random variables y1 through yn. And then we assume that they're independently and identically following a normal distribution. So the joint density, as we did the review before, it's going to be written out as the product of each of the marginal, because they're independent. And then you're able to write each of the density into this. So in this unit, you will see that we're going to start to simplify terms a little bit more, because we want to leverage using, like, say, well, now you're looking at each of the yi, right? But then sometimes you might be able to simplify it that you might only need to work with the mean or some other summary statistics. Okay, so keep this in mind, and we're gonna start working with how to figure out the Bayesian inference for the whole process. Okay. All right.